Ever wondered how we can tell if differences between groups are significant or simply due to chance? Enter the world of analysis of variance, or ANOVA. This powerful tool helps us understand the degree of variation within and between different groups of data, peeling back the layers of complexity to reveal the significance of these differences. It's a cornerstone in economics, aiding us in making informed decisions based on statistical evidence. In the next few minutes, you'll start to see data in a whole new light. Let's get to the heart of ANOVA, how it works and why we need it. Analysis of variance, or ANOVA, is a statistical tool that breaks down data into two main components: within-group variance and between-group variance. Imagine you're comparing the economic growth of different countries. Within-group variance refers to the fluctuations within each country's economic data. Between-group variance, on the other hand, is the difference in economic growth between the countries. Now, ANOVA comes into play to tell us if these differences between groups are larger than what we would typically expect due to chance alone. In our example, ANOVA would help us determine if the economic growth patterns we see are truly distinct or if they could just be random variations. In essence, ANOVA is our statistical compass, helping us navigate through the sea of data and find meaningful patterns. So, not all variances are created equal, and ANOVA helps us see why. Now let's explore the magic of one-way ANOVA. One-way analysis of variance, or one-way ANOVA, is a statistical tool that allows us to examine the differences among group means in a sample. It's particularly useful when we have one categorical variable and one quantitative variable. Let's consider a real-world example. Suppose we want to compare the average incomes of different age groups. Imagine we have three groups: people in their 20s, 30s, and 40s. We collect income data, and we want to see if there's a significant difference in the average income among these groups. By using one-way ANOVA, we can do just that. In economics, this tool can provide valuable insights. It can help us understand how income varies with age, which can inform policies on wage growth, retirement planning, and even social security. So don't underestimate this statistical wizard. Remember, one-way ANOVA is your ticket to uncovering hidden patterns in your data. It's time to put your new knowledge to the test. Imagine you're an economist, trying to determine if different regions of a country have significantly different average incomes. You've gathered data from 3 regions. How would you use one-way ANOVA to analyze this? Ponder over this, and when you think you've got it, share your answers in the comments. Let's create a vibrant learning space where we learn from each other. So are you ready to dive into the world of data with ANOVA? Let's wrap up what we've learned today. We've delved deep into the world of variance, unveiling the power of ANOVA and how it propels economic analysis. We've seen the magic of one-way ANOVA and its unique ability to compare means of 3 or more groups. Our learning objectives have been met, and you've tested your knowledge, demonstrating a clear understanding of these concepts. With ANOVA, you're now equipped to make sense of complex data and draw meaningful conclusions. Happy analyzing!